This topic will cover transformations of conic sections. The first transformation we will look at is a translation by the vector AB. This can be found by replacing x with x minus a and y with y minus b in the equation of the curve. We can apply this to the hyperbola x squared minus 4y squared equals 1. Translating this by AB would lead us to the curve with equation x minus a squared minus 4 times y minus b squared equals 1. We can see that where the point of intersection of the two asymptotes was at the origin, on the transformed curve it is now at the point AB. The second transformation we will look at is a stretch. In the x direction, a stretch by scale factor a can be found by replacing x with x over a in the equation. And a stretch in the y direction, factor b, can be found by replacing y with y over b in the equation. So for example, the circle x squared plus y squared equals 12 could be transformed by a stretch in the x direction scale factor a to give us the curve of the equation x over a squared plus y squared equals 12. Notice that this circle is now an ellipse. Next we will look at a reflection in the x-axis. This can be found by replacing y with negative y in the equation. And for a reflection in the y-axis, we can replace x with negative x in the equation. Remember that the reason for this is that when we reflect a point in the x-axis, it's the y-coordinate that changes sign. And when we reflect a point in the y-axis, it is the x-coordinate that changes sign. So starting with the parabola y squared equals 2x, we can reflect it in the y-axis by replacing x with negative x, leading us to y squared equals negative 2x. Next we will look at reflections in the lines y equals x and y equals negative x. To reflect a curve in the line y equals x, we can replace y with x and x with y. And to reflect in the line y equals negative x, we can replace y with negative x and x with negative y. For example, to transform this ellipse x squared plus 8y squared equals 16, by reflecting in the line y equals negative x, we can replace x with negative y and y with negative x. This would actually simplify just to y squared plus 8x squared equals 16. That's because for this particular curve, a reflection in the line y equals x and a reflection in the line y equals negative x would actually give the same curve. This won't always be the case. Now pause the slide and consider what the equation would be for this ellipse. When you have done that, carry out each of the 5 transformations shown on the original ellipse, writing down its new equation and sketching the new curve. So the equation of the ellipse, we can see that it crosses the x-axis at 6 and negative 6. So we have x over 6 squared. We can see it crosses the y-axis at 2 and negative 2. So we have y over 2 squared. This equals 1. We could expand this out to give us x squared over 36 plus y squared over 4 equals 1. This could be simplified further to give us integer coefficients. If we multiply everything by 36, we would get x squared plus 9y squared equals 36. So this is the original curve we're going to start with for each of these 5 transformations. Again, pause the slide if you haven't already carried out these transformations and then continue. So the first transformation we're going to do is a stretch in the x direction scale factor 3. So this is what the sketch looks like. It's the same graph but stretched factor 3 in the x direction. We can find the equation by replacing x with x over 3. So the second transformation is a stretch in the y direction, scale factor a half. So here we have the transformed graph shown here. And to get the new equation, we are going to replace y with y over a half. This is the same thing as replacing y with 2y. Remember to put the 2y inside the bracket so that it is squared. Next, we're going to reflect in the line y equals x. Here is the transformed graph shown. And to get the new equation, we need to replace x with y and y with x. So the new equation is y squared plus 9x squared equals 36. For the fourth transformation, we are going to translate by 0, 2. This means translating up by 2 units. So the new curve is here. We can see that it now passes through the origin and the centre is now at 0, 2. To get the new equation, we need to replace y with y minus 2. Finally, we're going to translate by minus 4, 0. This means translating 4 units to the left. We can find the new equation by replacing x with x plus 4. Now complete exercise 3C on page 74.